Hello, welcome to Module 4. I'm Hui Wang.
And I'm Neil Knobloch.
The purpose of this module is to examine how well do you do for your integrated STEM lessons units by using the framework of a STEM integration through agriculture, food, natural resources, which is AFNR, that Dr. Knobloch and I create for our course. After this module, you will be able to describe the level of integrated STEM through AFNR, identify level of integrated STEM through AFNR, review example lessons for ideas of integrated STEM through AFNR. This is the final steps of creating your integrated STEM lesson and unit. Please read the definition of a STEM integration again, and look back what you have done in Module 1, 2, and 3. In this module, we will dive deep to provide you more information about level of integration to help you have a better understanding about multidisciplinary, interdisciplinary, and transdisciplinary. In 2018, Dr. Knobloch and I co-created the framework to help our students exempt their integrated STEM through AFNR lesson. The framework helps our students to push the lesson more STEM integrated. The framework has 7 categories, and each category has 3 levels: exploring, developing, and advancing. We published the framework in the Journal of Agricultural Education in 2018. We welcome feedback from you after you use the framework to help us improve the framework. Due to we only have 20 to 25 minutes to give you examples of the framework, we will focus on the advancing level of a STEM integration. The first category is the roles of integration in the learning objectives. In this category, we would like you to extend lesson or units of learning objectives. One of the ultimate goals of STEM integration is to help students meaningfully learn and apply academic content knowledge through real-world problems. Therefore, we put applied STEM knowledge to solve problems as advancing STEM integration. The second and third category are the role of STEM concept, content knowledge, and the skills, present and use. If we consider advancing learning objective is to apply STEM knowledge to solve problems, it is not too hard to understand why in the advancing level, the present and the usage of the STEM knowledge and the skill should naturally and meaningfully used, applied to solve problems, and should be integrated, synthesized, and transferred into some kind of solutions. The fourth category is the role of learning outcomes. In the definition of a STEM integration, we identify integrated STEM education is intentionally and purposefully blending multiple disciplinary, both academic and vocational. Please see Module 2 or reflect on Module 2 to get more information about academic and vocational discipline and knowledge. Therefore, in advancing level, learning outcomes should focus on at least apply interdisciplinary concept and skill when solving the problems. In fifth category is the role of instructors and type of instruction. This category particularly relates to learner-centered teaching to help develop learners' 21st century skills, such as critical thinking that relate to problem solving. Therefore, in the advancing levels, teachers should do what they needed to do to help emphasize learner-centered teaching by letting students to decide the directions of the solution to solving the problems. The sixth category is the role of AFNR, content knowledge. This category is particularly useful if you wanted to integrate agricultural, food, and natural resources into your lesson. In the advancing level, AFNR should intentionally and purposefully blend into the lessons with other disciplinary. The last category is the role of students' thinking. This category is related to the role of instructor and type of instruction that should focus on helping learners developing 21st century skills, like system and critical thinking to solve problems. Therefore, your integrated STEM lesson and unit should not only help learners apply the knowledge that they learn from the lesson unit, but also engage and motivate them to search knowledge outside the lesson or unit when they try to solve problems. In this module, we use 2 integrated STEM AFNR mini units. Each one has 3 lessons to help you practice of using the framework. We have those 2 mini units in the resource that you can download if you wanted to have more details about the lessons when you do the activity later in this module. The first mini unit is byproduct. In these lessons, we explore everyday product and how they directly relate to swine, cattle, beef, and sheep. Students will learn the engineering design process through the creation of their own byproducts and simulate various processes in creating the item like lip balm and crayons with animal byproduct. Lesson 1 has objectives overview what byproducts from animals are and why they are important. Lesson 2 explore why sheep, and then why you shell sheep, learn wood, and also process of making fibers like yarn and fleece. Lesson 3 is about byproducts of bee. You can make lip balms and exploring how to produce on a large scale of bee production. The second unit is wood. These lessons look at the incredible nature of the wood. Wood is strong, lightweight, and is abundantly growing in trees. In this lesson, students will conduct several experiments collecting the data and analyze the data. Students will use information they learned from the data collection, synthesize the data to create and test a chair. Lesson 1 has objectives to test the wood density, buoyancy, and special gravity. Lesson 2 talk about wood strengths, and the student will conduct experiment to explain the correlations of wood strength and the density. Lesson 3 is a design challenge that students will create a chair that by combining with what they learned in the lesson 1 and lesson 2. So here is our activity now. So let's use the frameworks to exempt those 2 mini units. You can also download the framework in the resources. You will read, review, and score the 2 different units, byproduct and wood, by using the framework, which is 7 categories. Please see the table on the right-hand side of the slide. You will need to have pieces of papers to write down your score. The scores are 1 for exploring, 2 for developing, 3 for advancing. You will score each category for each lesson in a unit. After you have done scoring, please also enter your score in a quadrant link in the Module 4. We will have more information about the quadrant link in the next slide. This will help us keep a record of what you have done. So here is more information about this quadrant links. After you have all your score on a piece of paper, please use the provide link to enter your score. When you select the box, it will turn green. Please select only 1 box for your each row. You could also give us additional information how you come up with your score. Now, we'd like you to pause the module for 15 minutes to do this activity. After you enter the score in the quadrant, please resume the module. We will compare your scores and our score to give you a better view of using the framework to exempt the integrated STEM lesson units.
So now that you've had a chance to look through the lessons for byproducts and the wood product, let's take a look at how your scores compare to an expert panel of 3 different people. This was a panel that reviewed these lessons independently, and then the panel collaboratively shared their individual scores for each of these criteria for these lessons, and then they talked together, and the panel came to a consensus score, which you'll see on this slide. So, for example, you'll see byproducts for lesson 1. Learning objectives was given a level 2 at the developing level, and you'll see lesson 2 and lesson 3 were at the exploring level, level 1. Reading across that first row of learning objectives, you'll see the wood for lesson 1 and lesson 2 received a rating of a 2, which would be developing, and then level 3 for lesson number 3, which would be at the advancing level. So as we go through these one by one, we're just going to kind of highlight some of our rationale, but we'd also like to know your rationale. And so when you fill out the Qualtrics, hopefully you were able to provide some of the reasons why you rated each lesson for each of these criteria. So let's take a look at the first criteria in the rubric called learning objectives. And you'll see that for the byproducts, you'll see a score of level 2. We rated this because this particular lesson did take a look at connecting the agricultural activities to the engineering design with building the house about the 3 pigs. But you'll see that the other 2 were at that first level of simply creating awareness about a topic, either agriculture, food, natural resources, or STEM. In this case, it was agriculture, and it created an awareness, but it really didn't go into talking about the STEM connections. For the wood lesson, you'll see that this lesson 1, lesson 2 is scored at the 2 level, because you'll see that there's a combination of both science and mathematics being taught and how they relate to each other. So that incorporation of objectives were actually designed to teach the STEM skills and knowledge. Then for lesson 3, you'll see that it's advancing because it really helps students emerge in solving a problem using wood, and then trying to apply the concepts they learned in lesson 1 and lesson 2 to design a chair, and then to actually test that chair by breaking it to see what level of strength it had from the wood properties. We'll go to now the second, known as STEM connections, and this would be looking at the presence of the STEM connections in these lessons. And you'll see that across the byproducts, the expert panel scored these at level 1, exploring. The connections to STEM were not integrated, but all 3 lessons did do a very good job of helping students to explore the agricultural content through the various activities, especially helping them see that the byproducts that they talked about, such as chapstick, comes from different animal products. On the wood side, you'll see that the expert panel scored the lessons 1 and 2 at the 2 level, developing. As mentioned, that the STEM connections were there between the math and the science. You'll see density, buoyancy. There was some mathematical problem solving that took place in lesson 1. But then lesson 3 received a rating of a 3 because it really did push for meaningful STEM integration, where you had the natural resources present and helping to apply the science and the math that was learned from lesson 1. Now let's continue the conversation about STEM connections, but let's look at the usage of how those STEM connections were actually listed and drawn out in the lessons in these 2 different units. So for byproducts, you'll see that the expert panel rated 1 for all 3 lessons because the usage of this STEM content was driven by agriculture or ag, food, and natural resources, and really exposing students to become aware of where byproducts come from. There was not STEM content concepts taught in these 3 lessons, and so the students really didn't make those connections in a meaningful way, which is why that was scored a 1. In the wood unit, you'll see that the scores were 2, 2, and 3, respectively, for the lessons. Follows a similar pattern that the usage of math and science in lesson 1 is why there was STEM content knowledge being connected and being used. And you'll see then at the level lesson 3, it was a level 3 because it was really a fuller, more complete, holistic integration of how those science and STEM concepts of buoyancy and density were being taught in a way that actually was being useful in an engineering design approach of designing the chair and then actually using scientific inquiry to test and see what the evidence was in testing what that chair looked like or how strong that chair was with the wood products. So we'll transition now to the next criteria, and this is focusing on the learning outcomes. The expert panel scored the 3 lessons for byproducts at the level 1, the exploring level. This was because all 3 of the lessons focused on learning outcomes that were exposing students to the content of agricultural byproducts. Really did not engage students into making the connections to STEM in a way that the outcomes would be expressed. For the wood lessons, you'll see it's also a 2, 2, 3, respectively for these 3 lessons. It follows a similar pattern that at lessons 1 and 2, the focus was on the integration of how math and science were being learned together to help the students understand these concepts. And then lesson 3 was at the highest level of advancing because it really helped students engage in a meaningful problem-solving exercise of designing the chair and breaking the chair, and then actually measuring to see what the strength of the wood was in how they designed their chair. For instruction, you'll see that lesson 1 on byproducts was a 2, followed with 1 and 1, levels 1 exploring for lessons 2 and 3. These lessons were cookbook in nature, and the students really just kind of followed the instruction, the guidance of the teacher, and the teacher really had control in sharing with the students what steps they needed to do in order to carry out the activities. On the wood side, you'll see that the lessons were less cookbook, so there was actually mathematical problem solving in lesson 2. There was also a bit of inquiry with testing the buoyancy of the blocks of wood in lesson 2. And so the students were asked questions. What did they think? Make predictions. So you can see that's actually going more into a facilitating role as an instructor. And clearly at the 3rd lesson, students were given much more autonomy, and they could be creative, use critical thinking, try to apply these science and mathematical concepts as they then design their chair using the engineering design process. So you can really see a fuller integration of the STEM and how then the instructor played the role as a facilitator in that 3rd lesson for the wood unit. So because this is done in the integrating STEM in the context of ag, food, and natural resources, we also want to take a look at what role the AFNR content played for these 2 units. For lesson 1 under byproducts, you'll see it received a score of 2, followed with a 1 and a 1 for lessons 2 and 3. The AFNR content was actually connected to, the agriculture content was connected to an introductory way of engineering design with building the house using the different products or food products in lesson 1. But most of this was simply an activity-oriented lesson. And so you can see that the focus was on experiential learning in a way that it was really learning about agricultural products, but there wasn't that integration level of making the connections from agriculture to STEM. On the wood unit, you'll see that there's a 2 for lesson 1, developing level, and then lessons 2 and 3 received an advancing level at the level 3. And so this was where the wood not only became part of the context, but it really became part of the problem-solving process, and understanding that woods have these different properties, they have different strengths, which really are based upon science, and we use mathematics to then start to understand how they work, or how they're actually expressed. And then you have, I guess, in the third lesson, where the wood was really the product that was used to design the chair, and then that was tested. And so it really kind of brought it all together in that interdisciplinary way. So you'll see there's a contrast between these two units and how the AFNR content played a role. For student thinking, you'll see that the expert panel rated byproducts at level 1, the exploring level, for all 3 lessons. Students were given opportunities to engage in activities, but the activities pretty much were thinking inside the boxes we may use as a metaphor, where students were given different resources. They carried out what the activity, the hands-on activity, was asking them to do, but it really didn't introduce them to solving problems or thinking in an inquiry way much beyond just having fun with the hands-on activity. In the wood unit, you'll see that the student thinking was rated at level 2 for lessons 1 and 2, and then lesson 3 was advancing at the level, lesson 3 was advancing at the level 3. So students were given the opportunity to think more creatively outside the box, especially with the third lesson, because they were able to create and design a chair, and they were able to build it, test it for strength. And so that was a way to really get them to think more critically, creatively, and kind of thinking about how the science really was, the properties in the wood were then going to help them to make a stronger chair. So now I would like to share, before we go to the reflection questions, I would just like to share that there is an addendum to the rubric that will be discussed, or was discussed, in module number 3, that focuses on making connections, cultural connections, community connections, as well as career connections. And so you'll see that there's additional ways to even make your integrated STEM lessons more robust and more inclusive as you make the connections going through the modules number 3. Now, as we wrap up this module, you'll see that we have a few reflection questions for you. So the first question: how do I differentiate between single discipline, multidisciplinary, interdisciplinary, and transdisciplinary? Hopefully by going through these lessons, you're able to see the difference between single discipline, multidisciplinary, and interdisciplinary as expressed through these 2 different units. The second question focuses on how can you incorporate these ideas, these different criteria at these different levels in your classroom with your students. And then to reflect about, if you are doing this, what levels of integration are you doing? Are you doing exploring, developing, or advancing? You could also think about, is it multidisciplinary, interdisciplinary, and transdisciplinary as well? And then the third question we want to leave you with is, how were your answers about the lessons different than what the expert panel saw? And just think about that this was based upon our interpretation and your interpretation with your differences of experiences and how we might have seen that. But the idea is not about getting to maybe the right rating or the correct rating, but really understanding and being able to apply it or interpret when you see integration happening at exploring, developing, and advancing levels. You understand why and how that may look as you engage in this process of developing your own lessons and, of course, implementing them with your students. So for the next step, as you continue to develop your skills of integrating STEM through AFNR, we want you to think about what this might look like in one of your classes, or maybe with a few classes. Do you do some projects already that would integrate STEM and maybe make the connections, or use ag, food, and natural resources as a means in which you can do even greater STEM integration? We'd like to share a few acknowledgments. The graduate student working on this project, Brianna Nelson, helped organize and develop the slides for this module and has done an excellent job. We also were supported by funding from the National Institute of Food and Agriculture and the Hatch Project. If you have any questions, feel free to reach out to Dr. Wong or myself. Thank you.